Hello, welcome to Madam YY channel. Today we are going to discuss chapter 1, Matter. So the learning outcomes for today we will include how to define element and introduce the period and group of elements in the periodic table. So we will only limit to group 1, group 2, group 13 to group 18. And then we will discuss on 1.4 physical and chemical changes of matter. Elements is a pure substance that cannot be broken down into simple substance by chemical means. So element is made of one type of atoms. So they have identical atoms which are physically and chemically identical. And each element has its own unique physical and chemical properties, but there are important patterns we can see when we are looking at the element down the vertical column or across the vertical column in the periodic table. So this is example of the first 20 elements in the periodic table, and you can see they are a single letter or a big capital followed by a small letter used to denote the element. So these are the chemical symbol which can represent the element, such as hydrogen we use H, helium we use He, lithium Li, and so on. So periodic table is an arrangement of elements in order of increasing proton number. So elements are grouped in the same period because they have the same number of shells filled with electrons. So for example, across period 3, the elements are all having 3 shells. And the vertical column in the periodic table are called groups. The elements with the same number of valence electrons in the outermost shells are gathered in the same group. Same number of valence electrons in the outermost shell cause the element in the same group to have similar chemical properties. And elements can also be divided into metals, non-metal, and metalloids in periodic table. In the periodic table, we can see that hydrogen has 1 proton number, helium 2 proton number, lithium has 3 proton number, barium has 4 proton number, boron has 5, and so on. So that's how elements arrange in order of increasing proton number. And in the periodic table, on the right side of the periodic table are normally metals. And metals are a good conductor of heat and electricity. And on the left side of the periodic table, normally we have the non-metals. So non-metals are poor conductor of heat and electricity. And the metals and the non-metals, they are separated by a zigzag line, which you can see here is a zigzag light blue. So these are called this metal in the light blue column are called semi-metals. So semi-metals is also known as metalloid. So when across the column, it is called as period, and we have 7 periods in periodic table. And when down the column, the vertical column is known as group. So there are group 1, group 2, group 3 until group 12, 13, and up to group 18. So group 1 element is known as alkaline metal because they can form strong bases when they react with water. And group 2 is called alkali earth metal. And group 17 here is known as halogen. And then group 18 is known as normal gas because the element in the group 18 normally they have reached a stable octet configuration, which they will be inert to other atoms. So they're known as inert gases or normal gases because they do not react with element in normal conditions. So the next slide, we are going to see the differences between physical changes and chemical changes of metal. So physical changes occur when the appearance of the substances change, but chemically the substance is the same. So the individual molecule do not change, means that no new substance is formed because the chemical identity does not change. So for example, when ice melt, the water molecule become further apart, but the molecule is still a water, which they are still contain 2 hydrogen and 1 oxygen atom. So it means that there's no changes to the water molecule, only the distance between the molecule become further. So in the physical change, one or more physical properties is changed. So the physical properties include size, shape, physical phase, or state. Other examples of physical changes are melting, freezing, or changing size or shape. Or we can say a physical change also occurs when the substances are mixed or dissolved, such as when we are making salt water or cool air. So in the saltwater solution, in the saltwater solution, the properties of the salt and the water is still maintained at the original properties, and the substance can be separated again. So if physical properties or physical change happen, we can restore it to the original shape. Okay, so that's a physical change. So for example, here we have the salt solution where I dissolve salt in water, and then if we want to restore it to the original substance, we can do evaporating, where if we heat the solution, and then all the water will be evaporated, and then there will be salt, solid salt left in the evaporating dish. So we can restore the water and the salt. And another example is where the ice melt into water, so we can do freezing, to restore back to ice. So they are still, so for ice and water, they are still taste the same. The difference will be the physical state has changed from solid to liquid. So here are some processes that can produce a physical change. So for example, tearing a piece of paper. So this only change the physical properties such as the size of the paper. So the paper has changed from bigger to a smaller size, but the chemical properties of the paper is still the same. Or cutting oranges. So here the orange still tastes the same, but we only change the physical properties such as the shape of the orange. And another one, chopping a wood. So the size of the wood has changed, but the chemical properties remain unchanged. So next we are going to look at chemical changes. Chemical changes result in formation of one or more new substance. So in a chemical change, matter is transferred completely into different materials and new substances are formed. So the new substance will differ in chemical properties and composition from the original substance. So chemical changes usually occur when two or more substances come in contact with each other or when heat is applied. So for example, when we are baking a cake, so we mix the ingredients such as flour, eggs, sugar, butter. So these are different substances. So when you mix them together and when we bake, we have changed the chemical properties and the composition of the original substances. So the taste of the egg, flour have totally become different. So these are chemical changes. So there are some signs of chemical changes. For example, after a chemical reaction, normally the product cannot be turned back to original substance easily. So for example, once a paper is burned, it have turned into ashes, so we cannot restore it to the original state. And some other indication of chemical change include change in color, production of gas, production of precipitate, there will be creation of heat, cooling, light is given off, and also production of an odor. So these are another example of chemical change. So this is where the metal have undergone corrosion. So we can see the iron here has changed color. So this is where the iron has become rusty. So another sign of chemical change is the another example of chemical change is the digestion, which is like our life process. So for example, the food which pass through our stomach will undergo digestion, where they are being broken down into smaller and simple units. So the food will be absorbed by our body as nutrient or will be disposed or discarded as feces. So for this, we cannot restore it back into the original food, such as bread, chicken or milk. So these are the example of chemical change.